Okay, good morning everyone. So let me begin today's class with a bit of numerical problems for continuous time Fourier series. And as we proceed, we'll discuss about continuous time Fourier transform also, if time permits. And later on, I'll be sharing few more recorded videos. Okay, so see to it that you have to go through all the recorded videos which have been posted. Okay, so it is for your benefit that I'm doing such things. Okay, so see to it that you are going to make the best use of it. All right, so it becomes difficult unless and until if you don't work on the numerical problems, it would be difficult for each and every one of us. Okay, so see to it that you are going to solve more and more number of numerical problems as we proceed. Okay, so let me begin today's class. Let me start sharing my screen now. Okay, yes. Okay, so yes, I think we had done with some numerical problems which have been related to the continuous time Fourier series. Okay, so we had a bit of the common period, that is the fundamental period which was there. Okay, then we had to find out the Fourier coefficients, and then we had to like sketch the amplitude and the phase spectra. Okay, so let us go on to this problem which is related to Parseval's theorem. Okay, Parseval's theorem. Okay, so now can anyone unmute themselves and they can tell me what is the equation related to Parseval's theorem? Okay, can anyone unmute themselves and they can tell me what is Parseval's theorem? I hope everyone is in the meeting, right? X of t. Yeah, okay. Yes, can anyone tell me the equation related to Parseval's theorem? Yes. So the Parseval theorem is related to the average power of a periodic waveform. Okay. So where you will be having the average power of the given waveform, that is by 1 by t. Okay. So that is over the time period. So where you are going to take the magnitude of the given signal and square it, that would be equal to dt. So in terms of the complex Fourier coefficients, you can express as sigma k is equal to minus infinity to plus infinity x of k under the mod, that is squared there. Okay, so this is what we were doing there, and we are taking the conjugates and then we are taking the magnitude of the both the complex thing. Okay, so the complex Fourier coefficient and also its conjugate. Okay, so that's what we were doing there in case of the Parseval's theorem. Okay, so we had a proof and later on we had a plot which was related to the square of the complex Fourier coefficients, okay, versus k. So it's a line spectrum of the power. Okay, so in the waveform we generally call it to be the power density spectrum. Okay, so we generally call this to be power density spectrum. Okay, so we will be doing it and we are going to have a power density spectrum being analyzed. Okay, so now you have x of t that would be equal to 4 plus 2 into cos 3t plus 3 into sin 4t. Okay, so we have to consider that periodic waveform. Okay, so what we are going to find is, okay, so what is the value of t? So you are going to solve a more number of problems here. So I'll be giving it to you. So you have to solve it and do let me know the answer as soon as possible. Okay. So what is the value of t? What is the total average power? What is the total average power? Okay. So third one, find the complex Fourier coefficients. Okay. Next, using Parseval's theorem, using Parseval's theorem, find the power spectrum. Find the power spectrum. Okay. Next, fifth one, show that the total average power from part D. Okay, so this one is part D here. So that's what 4 from 4 agrees with what you have obtained. You have obtained what you have obtained in part 2. What you have obtained in part 2. All right. So first one, what you are going to find out, the simple one, that is the total time period T. And second one, what is the total average power that is there. Third one, find the complex Fourier coefficients, that is x of k. All right. So fourth one, using Parseval theorem, find the power spectrum. Fifth one, show that the total average power from 4. Okay. So that is what you get here using the Parseval theorem, agrees with what you have obtained in part 2. So this one, where we are going to find out the total average power. Okay. So next, what we are going to do, you are going to find using the Parseval theorem, and both the thing agrees. Okay. So both the values that you get, so it would be of the same value. Okay. So I think the first part is quite clear to each and everyone. So how are you going to find the T? Find T, the fundamental time period. Generally, you have a DC term. Okay. So what is the DC term here? Can anyone tell me by unmuting themselves? 4 plus 2 times cos 3t plus 3 times sine 4t. So what is the DC term in this periodic waveform?
4.
Exactly. So 4 is said to be the DC term. So there is no frequency that is associated with respect to 4 here. The frequency is said to be 0. That's the way we are going to call this to be the DC term there. Okay. So now what we are going to do here is, we are not going to take the DC term's frequency here. So in x of t. Okay. So you have the first one, which is said to be omega naught 1. And second one, which is said to be omega naught 2. Okay. So omega naught 1, that would be equal to 3 radians per second. Next, omega naught 2, that would be equal to 4 radians per second. Okay. So what we are going to do while you are calculating the fundamental time period? So what is the thing that you will be doing now? So you are going to take the GCD. So GCD of the frequencies, that is omega naught 1 and omega naught 2. Okay. So GCD of two terms, that is omega naught 1 and omega naught 2, which is said to be 3 and 4. All right. So now if you take the GCD, that is nothing but the greatest common divisor. Don't get it confused. Okay. So we are taking the GCD of the angular frequency. All right. So that is where you have to find out the GCD of two angular frequencies, that is 3 and 4. So GCD is said to be 1. Okay. So where the time period, okay, so omega naught, that would be equal to 2 pi divided by t. So omega naught is with respect to the fundamental frequency in radians per second, right? So omega naught 1. Okay. So now the time period, fundamental time period will be 2 pi divided by omega naught. So t would be equal to 2 pi divided by what is omega naught? That would be equal to 1. So the time period, that would be equal to 2 pi. Okay. So t will be equal to 2 pi there. Okay. So that's how you are going to do it. And such problems are being repeatedly asked there. Okay. So see to it that you go through each and every concept. First one, you are going to find out the fundamental angular frequency. Okay. So that is with respect to 2 pi divided by t, taking that equation. All right. So t would be equal to 2 pi divided by omega naught. Okay. So 2 pi divided by omega naught. So that is 2 pi divided by 1. Okay. That would be equal to 2 pi. Okay. So 2 pi divided by 1. Okay. So t would be equal to 2 pi seconds. All right. So t would be equal to 2 pi seconds. Okay. So now x of t, you are taking the equation there. So we are going to take GCD of both the frequencies, that is 3 and 4. Okay, so that's how you are going to find out the time period. Okay, so that is 2 pi seconds. Okay, so the second part, what it deals, so what you have to find out, you have to find out the average power. So it's quite simple. So let me tell you one more time, so how you are going to take the average power there. Okay, so that would be P. So we are not taking the Parseval theorem into consideration. Okay, just remember that. So P would be equal to 1 divided by T integral over the time period. Okay, so over the time period, x of t, which is the modulus of it, okay, squaring the modulus of it and integrating it with respect to dt there. Okay, so what you are going to do, what is t here, what is t? T is 2 pi. Okay, so t is 2 pi integral. Okay, so integral, so you are going to take it over the time period. The total time period is 2 pi, so it would be from minus t by 2. Okay, so what is the integral limits there? So if you can recall, so it would be from minus t by 2 to plus t by 2, isn't it? So minus t by 2, you are taking it, and again you are taking the plus t by 2 there. Okay, so now you are going to integrate it with respect to dt. Fine. So now you are going to have integral minus t by 2. Okay, minus pi to plus pi. Okay, minus pi to plus pi. Okay, so what you are going to do, you are going to square the x of t waveform. Okay, so 4 plus 2 times cos 3t plus 3 times sine 4t squared dt. Okay, so now I'll leave this to you. Okay, so I'll leave this to you, and see to it that you are going to get the answer. Okay, so can anyone solve this limits here? Yes, can anyone solve this and let me know the answer? Integral minus pi to plus pi, 4 squared. Okay, so 4 squared dt. Okay, plus integral minus pi to plus pi, 3 integral terms you are going to get it once I do the, like, take the integral, 2 cos 3t squared dt. Okay, plus integral minus pi to plus pi, 3 times sine 4t. Okay, square it dt. Okay, so now can you tell me that?
Sir, we should split in the form of a plus b plus c the whole square, no, sir.
Yes, see here. So this is the integral term. So I'm taking the integral term inside here. So integral operator, I have done it here. Okay, hope you are able to see this. So what we are going to do here is we are going to take x of t, and this integral term is with respect to the individual cosine, sine, and also the dc term which is being present here. So it is not like a plus b the whole squared. So we are going to take this integral operator inside. And if you remember what we had done in the orthogonality concept also, then you can able to understand this. Okay, so you'll be directly telling me the answer. So what is the answer is, so both the cosine term and the sine term are with respect to orthogonality concept, theorem 3.1. So those terms will get cancelled out. Okay, so those terms will get cancelled out, and you are going to left out with the terms which are there. Okay, so you are going to have the terms like you just have to square the amplitude factor which is there with respect to each and every one. So that would be 16 plus 4. Okay, so next you are going to have the term here. Okay, so you are going to have 9. Okay, 9 divided by 2. This factor is also being taken into consideration. 2 pi factor is also taken into consideration. You are going to, like, solve it there. Okay, so can you quickly solve this and let me know the answer for this? Yes, Rahul, what you said is correct. But integral here we are dealing with respect to the orthogonality set here. Okay, so sine and cosine function forms the orthogonality concept. Yes, can you solve this integral? Integral 1, okay? Yes, can you solve it? It's quite simple, isn't it? So you can solve it and do let me know the answer. Okay. So the answer would be 45 divided by orthogonality concept, sine and cosine would get cancelled. Okay, so if you do it via integration also, if you square it and you can do it, so both the things will be getting cancelled. Okay, so see to it that you are going to follow the theorem number 3.1, which is there with respect to the orthogonality of the signals that is there. Okay, so now the power is set to be 45 by 2 watts. Okay, so see to it that you are going to do that. Okay, so the next concept is x of t. So what is the third one? Okay, what is the third one there? So you have to find out the complex Fourier coefficients. Okay, x of t, that would be equal to 4 plus 2 cos 3t plus 3 sine 4t. Okay, so x of t is being given like this, and how we are going to express in terms of the exponential functions, the cosine and the sine function. So we are going to, yes, e power j 3t plus e power minus j 3t divided by 2. Okay, next this one 3 times e power j 4t plus e power minus j 4t divided by 2. Okay, so now what you have got it here, so we know that. Okay, so how you need to write this? So 2 gets cancelled here, fine. So it is 3 by 2, 1.5 we are going to get, I think 2j here, isn't it? So sorry, yes, so e power j40 minus e power minus j40. Okay, so now what you are going to do it from here onwards? I think you are not like going through the concepts that we have done previously, so see to it that you are going to do it. Yes, can anyone tell me what we are going to do? 4 plus, let me expand to make you clear, plus e power minus j 3t plus 3 by 2j e power j 40 minus e power minus j 40. Okay, so now can you tell me how we can expand this? So you have an equation, right? That is x of t, that would be equal to sigma k equals minus infinity to plus infinity x of k e power j into k into omega naught into t. Okay, so what is k here? K is nothing but the complex Fourier coefficient, that is x of k. The value of k, if you give it, so you have omega naught would be equal to 1 here. Okay, so omega naught is equal to 1. All right, so once you have e power j into k into omega naught. Okay, so the value of k is not equal to 1. Observe very carefully here, the value of k is not equal to 1. The value of omega naught will be equal to 1 here. All right, so that is one thing that you need to observe carefully. Okay, so you have the value of omega naught, so take the value of omega naught on comparing this equation. Okay, so omega naught value would be equal to 1, and if you expand this, so then you are going to get the value of the complex Fourier coefficient. So you have x of k, so that would be equal to the k value. K would be plus or minus 3. Next, k would be equal to plus or minus 4. Okay, so next value k is equal to 0. What does k is equal to 0 mean? What type of term you will get?
Average power.
Yes, no. Yeah, so k is equal to 0. You are going to get a DC term there, right? So that matches with 4 here, isn't it? So you're going to get the DC term of the complex Fourier coefficient x of 0, that would be equal to the DC term which has been associated here, isn't it? So x of k, x of 0. Okay, so that is what you are going to get here. So the value of x of 0, that is x of k, that is when it is equal to 0, you are going to get the DC term, that is 4 here. Okay, so now let me check with all the complex Fourier coefficient here. Complex Fourier coefficients. Complex Fourier coefficients. Okay, so I have x of 3, next I have x of 4. Okay, next I have x of minus 3, next x of minus 4, next I have x of 0. Okay, so now you can fill in the blanks. Yes, you can fill in the blanks now. Yes, you can solve it and share the answer with me right now. Yeah, how will you find out x of k? That is x of 3. What is x of 3? How you are going to find out? Yes, I need an answer. There is no point in me solving each and every problem. So in a given problem, you need to analyze. These concepts are simple.
X of 3 equal to 1.
How did you get x of 3 is equal to 1?
Comparing with the equation x of 3 is equal to summation of
Okay.
k is equal to
So
minus
you
n
are going to
to
take the summation, you are going to reduce it, where k would be from minus 4, okay, to plus 4, isn't it? So how we are going to expand this summation to get the value, okay? So that is where it has been entirely dependent on. So you can observe the coefficients, what I have expanded there, right? So x of 3, that would be equal to 1, and similarly x of minus 3 will also be equal to 1, okay? So now x of 4, can anyone tell me what is x of 4 and x of minus 4? I know that x of 0 is 4. So what is x of 4 and x of minus 4?
3 by 2j and minus 3 by 2j.
Very good. Okay, so 3 by 2j is for x of 4 and x of minus 4 will have minus 3 divided by 2j. Okay, so that's how you are going to do it, where you have x of 3 and x of minus 3 to be equal to 1, and that would be same there, right? So x of 4 and x of minus 4. Okay, so x of 4 and x of minus 4, so that would be equal to 3 divided by 2j, and the DC term is x of 0, that would be equal to 4 there. All right, so now moving on to the next one. So we have to verify it by Parseval's theorem. Okay, so now it comes the Parseval theorem concept here. Okay, so see to it that you are going to understand what is the equation which is related to the Parseval theorem. So P would be equal to sigma k is equal to minus infinity to plus infinity, that is x of k under the mod, you are going to square it. Okay, so now what is there here? So P of minus 4. So what is the power here? So you are going to square the complex Fourier coefficients. All right, so x of minus 4 that you are going to get. So what is x of minus 4? Go back to the complex Fourier coefficients if you have done it. So x of minus 4, that would be equal to, all right, so that would be equal to this one. Yeah, x of minus 4, that is minus, yeah, so minus 3 divided by 2j, minus 3 divided by 2j. Okay, so anywhere you are squaring it, not a problem. So take the modulus of it and square it. Okay, so what you are going to get?
9 by 4.
Exactly. So you are going to get 9 by 4 there. Okay, so now P of minus 3, P of minus 3, x of minus 3 equals x of 3, that is equal to 1. 1 squared is 1. Okay, so now P of 0, again P of 0, what it is? That is equal to 4 squared. Okay, so you are going to get it as 16. So we are taking the power here. Remember that we are taking the power. Next, P of 4. What is P of 4 there? That is again 9 by 4. Next, P of 3. That is again 1. Okay, so you are going to square it. I am just directly written here P of minus 4, that would be equal to x of minus 4 under the mod, square it. Okay, so that's where you are going to get P of 4 equals P of minus 4, that would be equal to 9 by 4. Okay, next P of 3 and P of minus 3, that would be equal to 1. Okay, next P of 0, that would be equal to 16. Okay, so we all have these components that are there with respect to the average power using the Parseval's theorem. Okay, so now what you are going to get? You are going to get P, that would be equal to sigma k equals minus infinity to plus infinity. So that is x of k the whole square. All right, so now what you are going to get? So sigma, if you need to cut down, that would be sigma minus 4 to plus 4 x of k under the mod, square it. Okay, so now what you are going to do? X of minus 4, okay, plus x of, yeah, so this one x of, yeah, let me expand this, x of minus 4 the whole square. Next, x of minus 3 under the mod, squared, plus x of 0 squared, plus x of 3 squared, plus x of 4 squared. Okay, so now x of, yeah, so you are going to get 2 into what is x of 4, that is 9 by 4. Okay, so why I have written here? So these two will have the same values and its magnitude, which is with respect to the same value, which is 9 by 4. So 2 into 9 by 4 plus 2 into 9 divided by, sorry, 2 into, sorry, so 2 into x of 3 and x of
1.
Yeah, that is 1 plus 4 squared, that is 16 then. Okay, so that's how you are going to get. So 2 into 9 by 4, 2 ones are 2 twos are, that is 9 by 2 plus 2 plus 16. You are going to get it as 45 by 2 itself. So using the Parseval's theorem, you are going to find out the complex Fourier coefficients, and then you are going to square it, and then you are going to compare it with the average power that you have obtained there. Okay, so these are the similar steps what we are going to do. So Parseval theorems is being found valid. Okay, so this is how we are going to do a simple problem on Parseval's theorem. All right, so now let me give a simple problem which is already been there, so you can just look into it. Find the complex Fourier coefficients, okay, the power spectrum, and the total power, that is nothing but the total average power. Okay, so that is the total average power of x of t, defined as x of t equals 5 sine of phi t plus 7 cos 60 plus 3. Okay, so you have to find out, also find the total power. So find the total power if x of t were a voltage. Okay, so what I'm doing here is I'm taking it as the two parameters here. Okay, so x of t, I'll take it as voltage and also the current. X of t were a voltage across 10k ohms, and the second one, and x of t were a current through 1 milliohm. Okay, So that is where you are going to consider both x of t as voltage and also to analyze it, and it's quite a simple problem the way we had obtained. Okay, so one thing what you have to remember is p. Okay, so p total. Okay, so if it is were a voltage waveform, so resistance you are going to divide it by resistance, and current waveform. Okay, so remember both the things, simple Ohm's law concept that you are going to apply here, and then you are going to get the answer. All right, so now let me stop here. Okay, so I have one more recording to share with you, and I'll share it after this class ends. Okay, so see to it that you are going to look after all those problems that I have shared it with you. Okay, so few more problems I'll share it, and if you have any sort of doubts, okay, any sort of doubts which are there, you can reach out to me personally, and we will able to solve that. Okay, so let me stop recording now.